Hello everyone, my name is Maitresh Ravi. Our final project is real-time gas temperature and humidity monitoring. So we are using an DHT11 sensor which monitors temperature and humidity, and then we are using a gas sensor, and we are using an Arduino R4 Wi-Fi board, and we are using two LEDs, red one and green one, and also we are using a buzzer. The reason why we are using a buzzer is if the gas threshold value goes above the threshold that we have, then this buzzer activates. The green light shows that it's less than the threshold value. So for example, let's say we increase we put, so when it goes above that, it shows a red light, and we can see there is a straight spike here, like it is like 100 and then went to it 740 or something. And also the same with the uh, temperature. If we put here, and then we can directly see like 28 and 20, 29 28 degrees.
Here, this is our Arduino code, which connects the R4 Wi-Fi to the Wi-Fi and HiveMQ cloud using MQTT. It reads temperature and humidity from DHT11 sensor and has a gas level from analog sensor. And uh, these are being set up using the Arduino, and the sensor data is formatting as a JSON, like we can see in the strings, and published every second to the topic, like that we created lab sensors here. And if the temperature exceeds like more than 29 degrees, and if the gas exceeds like more than 300, it turns on the LED and buzzers as an alert. So overall, this data is used for the real-time monitoring visualization, like we are connected through InfluxDB and Grafana. And now my teammate Diksha will continue.
Hello everyone, I am Sridikshita Palepalli. I will now walk you through how the sensor data flows securely from the device into the cloud for real-time monitoring. Here we created MQTT credentials Ravi Maitresh in the HiveMQ Cloud Access Management tab. The user has published subscribe permissions which ensure secure two-way communication between the IoT device and the broker. These credentials are used in both our Arduino code and Python script. Once the device publishes sensor data like temperature, humidity, and gas values to the topic lab sensors, we can confirm that it's being received in real time using the Hive MQ Cloud Web Client. The incoming JSON messages prove that our MQTT pipeline is successfully working. And this is our Python script. This is InfluxDB config with the cloud URL, authentication token, organization, and bucket for storing time series data. And the MQTT config with the HiveMQ broker details, port, topic, and credentials for securely receiving IoT sensor data. Our Python script acts as a subscriber. It connects securely to HiveMQ, listens to the topic, receives the data, decodes the JSON, and extracts the key values. These values are formatted into InfluxDB line protocol, which is the required format for time series storage. This data is sent via an HTTP post request to InfluxDB cloud, where it's stored in our bucket. We created bucket named MQTT under the organization Rowan University. Finally, using InfluxDB Data Explorer, we can run live queries and view the latest temperature, humidity, and gas values from the last minute. This confirms that our sensor data is not only transmitted but also stored and queryable in real time. So far, we have collected over 13,514 rows of sensor data, and the system is still running, continuously capturing and storing new values in the cloud. Now, my teammate will continue and explain how this data is visualized in Grafana dashboards.
Hi, this is Mohan Krishna Chesetti. Till now, we got the continuous data in InfluxDB. Now, we connect the InfluxDB to Grafana by clicking on the data source on the left. Click on Add Data Source and select InfluxDB. And we need to enter the InfluxDB URL and our organization name and token, bucket name, and then we need to click on save and test to confirm the connection. This shows thus the connection was made between the Grafana and InfluxDB. Now we move on to the visualization. We use time series, gauge, and stat panels in Grafana to represent the real-time sensor data, that is gas, humidity, and temperature. The time series graph shown how temperature and humidity and gas level changes over the time. The gauge panel provides clear threshold based alerts for each matrix, while the stat panel displays the most recent or average values of a quick monitoring. Together, they offer a complete picture of environmental conditions like how much is a gas, temperature, and humidity at the current temp. Finally, this project helped me to understand how IoT device MQTT, InfluxDB, and Grafana work together in a real time. I started with a basic knowledge, but now I feel pretty confident building smart monitoring systems that are scalable and insightful.
Implementing a complete IoT data flow was exciting and gave me hands-on insight into smart tech, inspiring me to explore edge AI and in future industrial scale applications.
So for me, this project helped me to learn like how data sent to the sensor. I mean, like the data is being taken from the sensors and using MQTT and store it and from the InfluxDB and then see all the things in Grafana, like visualizing it. And overall, it was very much fun using all these IoT devices and like and how it works in the real life. Thank you.